particular training. Yes, so this particular class, we'll be looking at some advanced topic. It will be more of like an introduction to some advanced stuff. So you probably still need to keep learning, because one thing about IT, about like generalists, like you continuously learn, you probably don't finish learning at a point in time. So today's class is going to be different. I'm not going to be anchoring it alone. I'm going to be so we know that during the class we virtually have two anchor, but most of the class only anchored by one person. But this particular one, I'm going to be anchoring it with Mr. Seun. Yes. So I believe at this point we have quite a number of people on the call already. So it's good enough for us to actually just start and dive into the class. So we have quite a number of things that actually prepare for us today. So we have we are going to be talking about different command types that we have. We've actually been using some of it. Majorly, yes, we're using majorly some of it, and then today we'll get to understand what those commands are that we've actually been doing. So more like get to understand what we've actually been doing before. And part of those commands type, they actually go into different categories or group. Part of it is data definition language. So we look a little bit in depth into that. Data definition languages that we have. We're going to look at the data manipulation language. Then we are looking at in depth into, we have different objects in databases, but one of the objects is view. We know table, we're working on table. Table is actually an object on database, in our database, which we're working on visually. We've been querying our database table, and we've done a lot of things with table, but today we are also going to be talking about tables, how to work with that. And we are going to be talking about CTE, yes, the common tabular expressions. Rank is a, so we're talking about rank. It's part of our query, part of more like the syntax when we do query. And we're talking about leads and lags. These are a little bit more advanced querying. So we're looking at that also today. And by the end of this class, I believe we'll be fully ready to pick up any tasks when it comes to database, when it comes to querying database, when it comes to being able to manage to an extent of our databases and our tables. Okay, but from like last class, what we've asked previously, do we have any question or any clarification we would like to get before we actually dive deep into today's class? Do you have any? I don't comment anyway. Okay. Okay, I will assume that we don't do. I'm looking at the chat. Okay. So I just actually none from me. Okay, all right. Okay, so let me just go to the slide. Let me just get into today's class. So we've been writing SQL query majorly a lot, but we focus majorly on select. That's been more of what we focused on in the class, because that's where that's language used. That's this command you use majorly in SQL, except you're a database administrator. But most people we use more of the select query more and more. So that's been where that's been where that's where we focused on more. But for us to know, select is not the only thing you do on SQL on our database using SQL. So there are different SQL commands. They are categorized into 4 different categories. And the first one is data definition language, DDL. So under our data definition language, you have different type of syntax. We have different type of commands, which is we have like the create. The create is basically use create to create database itself, create different database objects, which include our database table. So part of what we've been doing, we always run the create query most of the time at the beginning of the class to create the database we are using. But that's like the create. It's also an SQL command. We have the alter. if you're changing anything on our table, if you probably want to change the structure of the table or something like that, we have drop, if you want to drop it, we have truncate, we have comment, and we have rename. And then the second one, so we'll be going deep into the DDL later on and DML. So the DML, that's data manipulation language. Data manipulation language. And that's where we have our select. I'm sure everyone is very, very familiar with the select query, the different formats which it could be. But also we have inserts under this particular category. Insert is how you actually get data into the database table, how you insert record into the database, how you add record into the database table. We have update if you want to change a particular record. We have delete to remove a record. We have merge. Merge is more popular in Oracle. I don't know if you have in SQL. So, and then we have the third category is data control language. Majorly for what we've been doing, we are probably not going to, we've not been using the control, because the control is actually used, the data control language is used majorly in giving rights to who can see what. So basically, on a database by default, the user we've been using mostly actually have the full right. They have right to select, to do all these other things, but you could actually want to give right based on what someone will do. You might not want to give someone right to be able to drop table, because if they don't need to be able to do that, you probably want to limit who you give those type of rights to. So that's what this is actually used for: to grant right and to revoke rights. And then we have the transaction control language. So there is this concept where in majorly in programming, if you have a system, for example, I have a system that is doing transaction that's supposed to debit someone and then credit another person. So these are two different transactions, right? So if the debit did not happen, you probably don't want the credit to happen or something like that. If one of them fails, if second one fails, you want to roll back or you want to save it. So you can use something like transaction control to be able to say, okay, if all this happens, if this happens, if this happens, if that happens, then save it. If any of it fail, then go back to the beginning. Don't save anything. So that's majorly what this transaction control is. So the commit is always when you say, okay, save, and rollback is more of like you're saying you should go back, you should roll back. So I'm just so we are not going to go in depth into these two, but it's good for us to actually know that they exist. Okay. And so let's get a bit in depth into that DDL, the data definition language. So in data definition language, I mentioned we have different type of command. We have the create command. We have the drop command. We have rename. We have truncate. Those are the major ones. So, so we are starting with the create. So the create command is actually used to create different database objects. Like creating our table, you can create a database table. You can create, there are different objects that we actually have in database. We have view, or we look at that later on. We're going to take us through that. We have, you could be index you're trying to create. Majorly when you're trying to create an object on database, use like create command. And they have different syntax depending on the object you are creating. But for example, to create a database table, it's always create table. You can see the sample I have here. It's create table, then we have the table name. In this case, this example, the table name is staff. Then create table, and then the columns we have in the database tables. So the different table columns that we're actually supposed to have. So probably the first column is staff ID, and then the data type. So I want my staff ID to be of data type integer. So that's like a number. Integer is number, is different number. So we have different type of data type. We have different type of data type in database. So we have like the integer, we have we have things like integer, which is supposed to be number, right? We have string that we can call text, which most time in database use things like varchar or nvarchar to represent that. So in our database, in this case, the staff name is nvarchar, and we are saying, okay, because nvarchar is a string, I want to limit how long how much space should database create for it so that you can accommodate. So because also you want to give it as much space as you think the name should reasonably take, but also not too much so that you don't take up too much memory space on the database. So in this case, I'm saying it should be staff name should be VACA, variable character actually that means VACA 100. The 100 is the number of characters that it can take. That's the maximum number. So anybody's name that is more than 100, the database is not going to save, it's going to return an error. But also, so you probably look at it and be like, okay, name of people should not be more than 100. If it's more than, if you think it's more than 100, you can make it 200. You can increase it actually. Then we have department ID, which is also a number, and then maybe the salary. These are some of the things that we probably want to save. So this is the syntax to create table. So we can, so I think at this point, we can just go into the platform we've been using for our training, and I would like us also to try to create some database table. Okay. So do we still remember we've been using SQLite online, but I'm going to drop it in the chat in case you don't have it open. So we've been using the SQLite online. That's the platform we are using for today's class. And then we are using the MS SQL option down here. So as I mentioned, one of the commands, one of the SQL command, the DDL under the data definition command is to create table. So for example, we say in that example, we say we want to create. So the syntax starts with, let me just start with create. Then what follows this table before we have the table name. So let me say I'm creating table stuff. And after that, you have your open and closing brackets, normal brackets. Okay. So you have that, and then you can define the columns we want our table to have. So the script we've been using to create something. If you've actually looked at it properly before, we notice we actually have that code in it. Like at every point, this is the code that actually creates. This is the script you've been using, right? Let me copy it to. This is the script we're using to create our tables. But if you go to the beginning before you start inserting, you notice there's actually a syntax on like 910 here that says create customer. Customer is the name here. And then within it, we have the different columns. Within it, we have the bracket and we have the same brackets, the start and end bracket. And within those brackets, we have the columns that it should have. I don't know if you noticed this. So this is what we're actually trying to learn today, that how can we create our own table? So because here we've been creating some tables. So today, we just want to create a table. So part of the columns that we are creating, so the columns, so the database, the table is table itself, but within the tables, we have different columns of what you are saving data. So if you are saving data of our staff, so what are the record of staff that we want to save? So probably we want to save the staff ID. And then the data type of what are we expecting as staff ID? Is it supposed to be a number? Is it supposed to be a string? Let me even drop this link for them. So for this example, my staff ID is going to be a number, so I'm using int as the data type. Int means integer. So integer is number without decimal points, so it's not going to allow decimal points. That's what integer represents. And then so the second column staff underscore name. So this one I'm putting a variable character of length. Still use length 100. Maybe department ID, but I'm not using department. Let's just use department name. Department name, department of the person. And because it's a name also, it's going to be a a varchar. It's going to be a string. String is varchar also. So department name, how long can it be? Let's just say, let's say it's still 100. And then the last one, the last thing we have here is probably the salary. So the salary is not an integer because the salary can have decimal points. 1,000, 1,000 dots, 1,000 naira and 20 kobo, something like that. So because of that, we want to use decimal. And within decimal takes two, it takes two values. It takes the precision and the scale. So this version is this 18 is how long, how many characters can it take? And then the second value, comma, is the number of decimal points that allows. I don't know if we get that. So the first one we have, this first column we have, the first column we added is staff ID and the value is integer because it's just going to be a number without decimal points. Integer is number without decimal points. But then if I want one with a decimal point, I'm using a data type like decimal. So the syntax is simply, let me just write the syntax out. Table name, so create table, then we have table name, and within it, with brackets, we have column name, then we have the data type. So it comes in multiple, so different columns in my data type. So this is basically the syntax. This is the basic syntax. Zia, do you have any question? Do you get that?
Yeah. So I have a, can I go on? I have a question.
Yes. Go on.
Okay. So for the salary that is decimal, the 18,2, does it mean that we have two decimal there? Like decimal point?
Yes, so it allows up to 2 decimal points. So any other thing apart from the 2 decimal points is going to truncate. So I could have probably used 18, maybe comma 4 if I want an high level of precision. But also, so this 18 is number of so let me. So the way it works, the 18 is part of the number. So if I have this, just 18 is the total number of characters that it takes because once it overflows the 18, it's probably going to truncate or something. The data will not be correct. So like this, counting it from the beginning to the end, the number we have decimal point. Those are the 18 that it takes. So I'm now allocating out of this 18, I'm allocating 4 of it to be. I'm allocating 4 of it to be decimal points. That's what this is. So it takes 4 of it as part of decimal points. Yes. So we can run this. And now we have an additional table here. Okay, do you get that? Okay, so let's move on to the next. So the next syntax in our DDL, in our data definition language. So we have the alter. So probably there is something you want to add or you want to remove. You want to change part of the table. You want to change a column, maybe the structure of the table, which will probably be the column or something that you want to change. what we use for that is the DDL. So for example, if I want to alter, maybe, oh, I just remember that I'm supposed to add the hire date, the date they actually hire the staff as part of what, as part of the column. I need that data. I need to save it in our table. So you can, what the syntax to do that is just to use the alter table, then the table name, add the column name and the dates. So I'm trying to add a column in this case. So I'm adding the column name and data type, so not data type. So in this case, it's date. So data type is dates I'm using here. So let's just do that also so that we can have the higher date in our table. So I'm adding higher dates. So I'm going to say it's probably simple. So it's just this alter table name and then if this case I'm adding a table, so you can just run this, and then with that we have an additional column in our table, in our staff table. So now we have our table and we have the additional column of higher dates there. That's fine. Okay. So moving ahead, the next one is to be able to drop table. So dropping table is actually like if I want to delete it. So we have the table right now, right? We created the staff table. So we can also just drop it. So if probably for some reason we want to delete that table, we don't need it any longer. So you want to drop a table, you want to drop a view, you want to delete the database object, basically, we use the drop command. So in this case, if you're dropping a table, is drop table, then the table name. If it's a view, it's going to be drop view, the view name. So we can also try that, although we probably want to recreate, we try to recreate the table back. But we can run that drop table start. So if you run this now, so before we have the staff, we have the staff table here, right? If you run this, probably the staff table is removed, and then when you query, if you query that, you're probably going to get an error that table doesn't exist. Invalid object name. Are you with me? So at the end of today's training, we'll be sharing the slide for the slide that we're actually using from the beginning of the class, so that we can also practice and use as a reference point later on. But I still want us to get as much as we can get from this class. I know it could be a bit confusing. So, and then the last one I'm going to be covering under the data definition language is truncate. So truncate is basically for deleting the content of the table. So our table holds different, our table could hold data. So if you probably inserted records into it, and then you want to just truncate everything, you want the table to be as fresh as you just created it, you are using the truncate. There is a delete command in data manipulation and in DML that you can use to just delete a particular record. But truncate is more of like, okay, now it's like doing a format on your memory card. So it's going to wipe off everything in that table. So we can't do this now because we don't have any content in the table yet. So we do that after we test the truncate later on, after we've covered the data manipulation language, after we're able to insert it to the table. So let's just recreate the table because we dropped it for sure. Let's recreate it. So now we've created it and we can So we will test the truncate later on because there's no content in it, so there's nothing to actually truncate right now. But by the time we've been able to insert into this table, then we can come back and run the truncate command. Okay, so moving on to the next category of language of the language, the command that we have is the data manipulation language. This is where we've actually been doing a lot of what we've been doing, especially with our select query. So I'm not going to go to the select today because we already know that, I believe so. But there are other ones like the inserts. So add records into the table. We have the things like inserts. We have updates if you want to update a particular record. We have delete to delete a particular record, or probably you can even delete everything in the database with delete. And then we have the insert. We call them CRUD operation. CRUD means CRUD is CRUD is, let me see, CRUD. CRUD. And C means C stands for create. So the create here is insert. It's actually creating record, not creating the table. R stands for retrieve. And that's where we are. So U is for updates. And D is for delete. So the retrieve is select, is what you've been doing before, selecting data from the database. So the create here is the insert. The retrieve is it? Retrieve is this our select query. Update is update, delete is delete, so I'm not putting it in front of those ones. Okay. So in this case, let's look at the insert record. So we've actually been doing this a lot in our query and everything we've been doing, but I want to assume that probably we've not been looking at it very well. So the insert starts with the insert into. Okay, yes, let me just look at the form. The insert it starts with insert into, then the table name. And after the table name, you have an optional parameter of columns. So this is optional. If you are, it's majorly when you are trying to insert into every column, probably you don't want to insert to every column database. If you're inserting into every column database, you don't actually have to put this, you don't actually have to specify the column name. If you are inserting to all the columns in, and you have to do it. If you don't specify it, you have to do it in the order they have in the database table, in the database, in the table. And then the value is what you are inserting into it. So for example, the example here is inserting into staff, where staff name is John Doe. You are inserting John Doe as staff name. So it's corresponding. Value 1 is column 1. So yes, John Doe is going to staff name. 3 is going to staff ID, and 5,000 is going to salary. So that's where it is. Okay, so let's get to try that out. I want us to also try to do that, to insert record into our table. So the table, we've created a table called staff. So it's time for us to also populate that table with data. Insert record, insert into, then the table name. The table name is staff. The columns you're trying to insert into, you're inserting into staff. Staff ID, then to staff name. We're inserting to departments and then salary. Department name and then salary. So let's leave the higher dates for now. We can leave it out. So if we leave it out, what is nothing will be inserted to that column. It's just be empty. So let's just do it. And then the other, what follows is values. So the value is plural. And then we specify, we put in the what we are trying to insert into it. So the first one is staff ID. So because it's a number, I don't actually have to put it in string. So I'm putting my staff ID as 1, 2, 3. Then the second value here. So the second value, you have to follow the same order. Second value is staff name. So I'm using John. Which I'm using Adiola. Let's see, Rachel. Yes. So departments. You notice that around the ones that are string that text, I actually quote them with single quotes. You need to know that if it's a string, use a text okay, we've actually been doing that when we are even querying our when we are doing our selection, probably when we are trying to compare values that are string. So you always have to surround it with quotes there. So department name is IT and salary is $2,000. So because number, so okay, because we can also include dot into the. So with that, we've inserted the record into database into our table. So we can select everything from the table now and see what is inserted. So that's basically how to populate our database table. So we've seen how to create the table. If you need to alter it, how to alter it, probably you want to change something, you want to add a column, things like that. And also we are seeing how to insert record into the table. And then you can select that. See. So now we have our staff ID. Something, yes. Okay, so let me insert one more person. Control. So that's basically how to insert record into the table. So the next one we are looking at is the updates. Next thing we look at is updates. So if you want to update your record in database, you can update. So for example, probably want to come back and later on update like the hire date, the record about the staff. Basically, it could be the name that you probably want to even update. So how do you go about that? The syntax is simple, and it is update table name, right? Update table name. Then we can set the column and the value we are trying to set. So the column name we are trying to update and the value. And then the condition for it to update. If you don't have this condition, it's going to update everything in the database table. But most time you don't want to update everybody's record. You don't want to update the higher date of everybody to be the same thing. You probably want to update higher date of a particular staff. So the syntax is update table name, then set the column you want to update, column or columns. If there are actually multiple columns, you have a comma, then we have the other columns you want to update, and then the conditions. So the condition is okay, it's only people that satisfy this condition. So in this case, it's where staff ID equals to 5. So it's only anybody that the staff ID equals to 5 that is going to update. So the condition could be in different forms. It could be like you want to update everybody. Okay, everybody that is in this department, I'm trying to update their salary. Things like that. It could be different things that you're trying to, but it's important to actually add the condition. If you don't add the condition, it's going to update everybody in the table, in database table. Okay. So let us pick the first person we inserted, Richard, and update the higher date to be, so we can update the higher date to be a year ago. So let's look at update. The table name we are updating, which we are working on today, is staff, right? And what we are trying to update, the column we are trying to update is higher date. So we are setting it to be on 07 September 2023, so 1 year ago. And who are we setting it to? We are not setting for everybody. We only want to set for one person. So I can use different condition, but probably the condition I want to use is like staff ID, because staff ID, I know it's going to be unique to only Rachel. So I can use where staff ID equals to 1 to 3. Are we following? Is it confusing? Are we still here?
Yes, understood.
Yeah, I have a question.
Okay.
That set higher date. Remember you said that if it's a text value, you can put it in quotes. But are you saying in that sense the date the text value is?
I didn't get the question probably. You said, am I sure dimension?
Your query.
Yes.
That query after update stuff, then set higher date equals to, you put 07 September 2023 in quote. So is it because the quote is a text, that's valid the date September 2023 is a text value, that's why it's a quote?
No, so the higher date is when we created the table. When we added the table, we added it as dates. So for that I need to supply a valid date. So it's actually a valid date. I have a date, the month, and then the year. But also because of the way it could be, I have to put it in a quote because it's like a string, but it's not actually a string. It's still a date. I don't know if I get it, if that's the question.
Sorry, I was just trying to understand that the value type. So if it's a string, you have to put it in quotes, right?
Yes, if it's a string, you have
but
to put
if
it
it's
in
number,
quotes.
like when you were doing, okay.
If it's number, you
right.
don't necessarily have to put it in a quote. Although if you put it in a quote, it's still going to work. But you don't have to put it in a quote. So if I put the staff ID in a quote, it should still work. So let me confirm. But it should work actually. So I've updated this guy and let's see. Yes, so even though it's number, I can still put it in quotes and it will work, but you don't have to put it in quotes. But for string, date, and most other things, you have to put them in a single quote. Good. So now we run the query for updates for where we select the staff ID to be 1, 2, 3, and it's update that. So if we didn't have the staff ID, so let's say for example, we just type this without the staff, without putting the where clause. Let's say I'm setting to January. So without putting the where clause, and this is common, especially at the beginning stage, a lot of people make these mistakes. What this is going to do is going to update everybody's record. So in this table, we have 2 records. Now it has updated both dates, the date of both people to be January 7, 2023. Which is not what we intended. Probably we only want to set for this particular stuff. So let's set separately. Okay. And then our update, we can update more than one thing at a time. So for example, for this, for Ben Olabi, so I want to swap the name. I will probably want to change the name. Maybe I should also start with the last name and I start with the first name or something like that. So I want to update the name. So I can also put multiple conditions. So I'm updating the higher date, and then I'm updating. So let me change the date to August. August 2022. So I can update multiple things. So, so do it for so I need to put the where clause because I only want to update for one person. Where staff ID. So we can see I can have more than one value I'm trying to update, and the syntax just have a comma at the end of the first stuff, and then you can add the second one. So the column name, the value you're updating, the column name, the value you're updating, you can have it as much as possible for a particular row that you're trying to update. So if I run this now and select from the table, you should notice both the name and the higher dates has been updated. Okay, and it's not the last thing though. So I'm going to also the on the DML last one we are looking at is delete. So delete is basically you want to remove a record from the database table. Probably for some reason we don't want to remove this tab. Probably it's no longer a tab. Maybe Benjamin has left the company for another company and want to remove the record. So the syntax is simply delete from table, and then we have the condition we want to delete with. So for example,
Hello, sir.
delete from table name, and we have the condition that must satisfy for that project to be deleted. So similar to the update. So we don't want to delete every. So if you don't put the where clause, it's going to delete every record in the database table, which probably is not what we want to achieve. So we want to be able to delete. So if we want to delete, then so the syntax is delete from. So the from is optional in some database anyway. Well, I think we should learn the standard syntax. So select delete from staff. That's table name. The staff is table name. Where so who do you want to delete which record? So you want to delete where the staff ID is 321. So that's the second record here. Then the record. So let's just delete that. If you run that now it's as simple as that. The record is gone forever. So now our table only have one record, no longer two. If we forget to put the clause there, it's going to actually delete everything in the table. So for example, let's add back a record. So let's add back this record selector from it, so you can see that we have two records in database. So we have two staff. So if I run this guy, if I run this delete without the where clause, it's just going to delete everything it's just going to delete everything in database, not just one record. So now our table is empty, which is probably not what we want to do for us. So let's insert some record package in it. So now we have two records. So, but that's all on the DML. The other thing I wanted to show us was the truncate table that I mentioned earlier that we can't test because we don't have that yet, because we don't have any record. Now we have record in the table. You have two records. So if we look at the truncate, let's just quickly go back to the truncate. The truncate, the format is truncate table, then the table name. Truncate table, then table name. Truncate is literally deleting everything, wipe the table, wipe the whole content in the data in the table. We are not deleting just one record, we want to delete everything in that table. So that's what truncate is. It's just, as I mentioned, it's just like you are formatting the table. You want to format every record that has been added to that table. Except you are sure of what you are doing, most time it's not advisable to just truncate record from the database table because you might not be able to recover it in any way. So if I do this now, truncate, which is done, if you select from that table now, it's empty. Empty, no record. Do you have any question?
Yeah, I do have a question.
Okay.
Okay. So first I wanted us to see, or I want to know if I want to insert like into the table, but the information is going to different people. You get? Like it's not for the same person. Do I have to insert one after the other, or how do I go about it?
So you want to insert multiple records at once?
Yes.
So,
Yes,
okay.
but to different.
Okay, so let's just try that. Okay, so you can actually do this, which is each of the, so I have each of the records. So this is a record for one person, and then at the end of it, I have a comma, then I have the next record, I have the next record, I have the next record, something like that. You can do that, and then if we run this, okay, already let me check. Okay, there's nothing there. So if we run this, that's run. So that we should have we should have three records in the database now. Is this what you're trying to achieve?
No, I want to update. Sorry, I mean to say update. But to like, let's say I want to update information to Michael's, then update to maybe Adiola, to different people at the
The
same
same
time,
record,
or
the
do
same
I take
record. You are updating the same record or different records.
different record?
So for that, you have to. So since if the record is coming from it, if they are updating from another table, then you can probably do it. If it's not coming from another table, you have to do it one by one. I mean, if you already have the record, like probably if I have a record in a table that shows, if I'm using a table to update it, so maybe I have another table called staff salary already, then I want to update the record in this particular staff salary. So if there was another table, I don't have a table. But if it's not, even if it's not already on the database, that there's no, it's not contained in the table already or something, you have to, sorry, you have to like do that one by one. You can't update them. This record are not related. Assuming I have a table that is related, maybe we can try that. But the option you have with what you want to do is basically you have to write it one by one, one by one. Does that answer the question?
Yes, yes. Thank you.
Okay, all right. Thank you. So I'm going to be handing over to Shashion to continue from where Mr. Sharon.
All right. Okay. Thank you so much for that, Mr. Yomi. And I hope we've all learned one or two additional things. And I'm just thinking, I hope it won't be too much, but let's just get to business and see how far we can go with what we have today. So building on what we have so far. So let me share my screen. A minute. Sorry, 1 minute. Oh, please give me 1 minute. 1 minute. Yeah.
Okay.
Okay. Yes. Apologies. I think I'm back. Is this thing not showing? Okay. So sharing my screen now. I don't know how. Okay. Let me just bring up this guy. Yes. So today I'll be starting with view. So let's just go straight to what views are. See if I can move this. Let's put this guy in presentation mode. All right, yes. So view mainly, we use it for if we have a script, a complex script, so we can wrap it up inside a view, and that view, we can call it like our tables, like our normal tables. But what your view help you to do is it reduced your query time to some extent, and it makes your query a little bit easy to understand. So, and like we said here, the purpose is just to simplify complex queries and to catch your result. So it's like I've written the first query, I'll put the result somewhere, then I can now use that result to do other things. And also, you can use it to create a virtual relationships. So between your table. So if the customer table is related to the sales table, I can create that relationship, put them inside one view, then call that view later. So that's possible. And also, you can use it to customize your output, meaning that I want, for example, if I want to rename the columns within my data set or within my tables, so I can put that table in a view, and within that view, rename all those columns. So I can do that. And finally, I can use it to enforce business rules and ensure consistency across multiple applications. A good use case is if I'm getting customer data across our CRM database. So maybe we are using two CRM, one is Oracle, one is Microsoft Dynamics, all those things. And I want to pull everything together into my analytics. So I can get data set from different environments and now like enforce the business rules on all those columns within my view. Yes, so that's just the story around views. So let's quickly get into action with this guy. So let's imagine you are asked to create a view on your customer table and your customer order table. So for example, they want you to get total order by customer name. Remember, this is the environment we're using for our training. So we have our tables, we have our data sets. Let me move this guy out. Okay. So they want to get total number of orders by customers based on customer name. So what I can do, I can first of all say select star from orders. So if I do select star from orders, I can see the customer ID and the total orders by this customer. So what I can do, I can just get from here my customer ID and count of my orders. That's order ID. So that's count of my order ID. And this will be total order, right? And when I'm having an aggregate, what do I need to do? I need to put group by. Group by what? Customer ID. So this is my first result. So if I do this, that gives you your answer. So customer ID 2 has total of one order, 3 and the likes. But remember, what the business wants you to do is to what? Get total order by customer name. So let me put a question here. So at least you can say total order by customer name by customers. So I want my customer name and total orders, right? Remember, what we are trying to do is what? View. So at the end of the day, the view we contain just customer name and total orders, just 2 columns. But we need to walk through this process to get that information. So here we can see we have customer ID, we have total orders. So if I go to customers, select from customers. So if I do select stuff from customers, sorry, let me highlight this. Select stuff from customers. I can see my customer name and customer ID. So I need just those 2 columns. So the reason why I'm moving this way is I assume at least we've worked on joins before. So by the time I'm joining them together, at least it shouldn't be something complex, but we've done this before. And the reason why we're doing this is if you have any challenge, any scripting problem you want to do, it's good to solve them separately, bit by bit. Then you now consolidate your results in order to get the final table. So customer ID and customer name is coming from here, right? So if you run this now, it gives you, sorry, I need to highlight and run this. It gives you customer ID and customer name. Then what you can now do is you can join these 2 tables together, right? Hopefully this group by will allow this thing to work here because it can be funny at times. All right. So I can come here. So so if I come here 1 minute, I can say left join. This script, I can call this my script as B.
He's the only businessman I've ever known who could run a casino.
Hello? Okay, yes. Okay, so remember the main thing is we want to use view. So let me create this one, first one, before I join both of them. let me create view, create view, view. So what should we say this? What should we call this? Customer order, cost order. That's view one. So this is my view. Then I can create the second view as what? As my, I can just say customer details, cost details. That's my customer details. So see what I want to do here now. So if I highlight this, if I run this, we're looking at this side of my script. So the first script that we've written, I choose to put them inside view. So I can highlight this and run. Okay, wait. So I can since you use bracket or something. Okay. Select this. Okay. All right, perfect. So it's asking me for the hash. I can also, so if I scroll down, can you see customer order view? So this is my first view. Remember, I said the reason why you use view sometimes is to make your query simpler. So you can do those things that you need separately, create them as view. Then the view, you can now call it and use it later. So I can run this too. And I have, can you see customer details? So view one, customer order, view two, customer details. So having those two results, I can now come here and say, select star from my customer order view. If I run this, you can see the way I'm calling customer order like is an existing table like customers. So I can highlight this and run. You have your result. And I can also call the second guy, which is what? Customer details. Right? And I can also highlight and run. Right? And I can join both of them together. Let's use the where function so we won't be taking much time to join our stuff. I can just say this is my table A. This is my table A, comma. This is my table B. Right? Then I can say where. Table B. Why is it showing me Betty? Where A dot customer ID, customer equals B dot customer ID. Then in this place, what are the two columns that are important to me? What I need is here, I need customer name, my name, and total. So is it total order? Oh, I've forgotten how I placed it to. Let me see. Total order. Right? Remember, this customer name is coming from where? Customer details. So I can say B dot customer name. And total order is coming from what? Table A dot this. Hopefully, if I run this, I should have my result. And that's the result, where you have your customer name and your total order using views, right? So in summary, what we've done is that because we notice we'll be needing two set of queries in order to achieve this result, what we've done was to create a view for the first result, and we created another view for the second result. Then we merged together the two views. And yes, that's that using views. Do we have any question? Any concern?
I have a question.
Please go ahead.
Please, so when you're using at the left, does that looking function you have to use when you're using PhD?
So yes, and the reason why we are saying is why we have has. So these are select. Remember, this select is the whole script. It's like a query, which is expected to return a table, right? So a view is just creating like is creating something like that we call something like a variable that stores that result. You understand? So we are storing the result of this select into the variable called customer order, right? And that variable, we can use it, we can call on it like normal table that exists within our data set or use it for any other thing. Does that make sense? So you need to
Yeah.
specify the hash. Just and to some environments, you can ignore the hash and it will still work. I think you can in MySQL, you can just say create customer. No, it won't go. It won't go. That hash is important. I think it's important.
Okay, so
Yeah.
create is like a container, and then you can
Yes.
give it any name.
Yes.
Like customer
Yes.
view.
Exactly. So create view, the name of the view as, then you put the query behind it. So even this guy, this guy is a query. This guy is a query. I can create a view to store this query and I can say create view my result as, then it will use all these other ones. So I can run this. No, sorry. Let me highlight this. Create view my result as. So if I run this, then you can see my result now, right? And this is my result. I can come here, I can say select star from my result. You understand? So you can say select star from my result, then you still have your result. So it's just like a container for your script. So any script that you've written that is giving you a table, you can always put it inside view. So that's that about view. Any question? All right. Why is this thing not charging? Okay, yes. Do we have any questions? Any question? Let me just connect this charger. Any question? Do we understand? Is it clear? Any question? Okay, no question. So let's go to the next guy, which is common tabular expression. So common tabular expression is, let me put out this guy inside comment. I'm looking at our time, but it's fine. So your common tabular expression.
Ibrahim,
Yes, please.
I think it will be okay if you can send that query to enter the chat so that they can follow.
Okay.
Yeah.
Okay, let me copy all these things and drop it on the chat. So, but make sure you are highlighting each section by section. If you run everything together, it will throw up error. It will throw up error. Yes. All right. Thank you for that. Now, what common tabular expressions help us to do, CTE, is that you can see the stress of creating 3 tables. Because I want to get a final result, I have to create customer details, customer order. Although I can write everything together and use join, but I choose to make my script more explicit. Now, rather than me creating multiple views, in order to answer one question, that is where common tabular expression comes in. That, okay, do you have multiple tables to create, to work on? Rather than creating them separately, use common tabular expression to assign name to each of these tables and complete everything within one query. Let's see how that works. I wish I can push this guy to the side. Yeah, push. Okay, no push. Okay, so let's see how common tabular expression works. I'll be using the same example so that I won't be going back and forth. Still, we're given this problem to solve. So I'll just copy this. So total order by customers. Now we have solved this first table, right? I will copy this first table, right? And copy and paste here. Now, to use common tabular expression, we start with a command called with. So with, I can, all this query, I can say this is my table 1. With table 1 as, and I put this guy in the bracket. So that's my table 1. Table 1. Because we have 2 subqueries, in order to answer this, I can go and copy the second one and call this guy my table 2. Remember, I've put comma, right? I can say table 2 as open bracket, then paste this. Can you see the flow? With table 1 as this, comma, table 2 as this. Oh, as is too much. As this. Then I can now come and write my combining script, which is select a that. Let me just copy this because I can say because I can be lazy at times when it comes to typing script. I will just say rather than this, I will just change this guy to table 1, and this guy to table 2. Right? Then I can terminate my query here. You can see what we have done, what we have used multiple views to achieve. We are doing the same thing, but it is still within that same script, that problem we are solving. So if I write this, select b.name, select a.total orders, and table 1, I'm telling you that my total order is coming from table 1, and my customer name is coming from table 2. And I want table 1 customer ID to be equal to table 2 customer ID. So if I run this, all things being equal, let me highlight. Oh, okay, it's even working. It has worked because I've commented out this. Nice. So you can see, so if I run it, it gives me my result. But what's the difference? If you use common tabular expression, it makes your query clearer. At least people using your script can understand that, okay, first table 1, and they can highlight them session by session and execute. And with CTE, your script is easy to debug. So in case if something is failing, you can say, okay, I can say, okay, table 1, then table 2. So this table 1 and table 2, they are together. I can call this guy my table 3 if I have anything to do on it. But I should be able to see that, okay, table 3 is depending on table 1 and table 2. So that's the sequence. But you can see everything is in one script. So some people can say, when do you use CTE? So you use CTE when you know that the data you are modeling is only required for this script, like you're writing at this point in time. But you use view if other, how will I put it? If other table or other script or other query will require your table. For example, I can run an aggregate, keep it in a view, and another aggregate depends on that view. It's possible because your view is just like your tables. Yes, do we have any questions? So this is CTE. So the main thing is that CTE helps you to write a neater and clearer and more sequential script. And yes, everything goes on the fly. Ogochukwu, your hand is up.
Yes. Please can you give us use cases? So I see now that view table, create view is you're creating a container for your data, right? Now there's also tabular or the city. So what's the difference between the city, the tabular, or the tabular a
Common,
feature of the city is?
common tabular expression,
Okay.
right? So that's CTE. You can just put
Okay, so within your city clusters, then you now put tab one or tab two. Is it just anything you want to use?
anything. So this tab one is also a container like we had for create view customer details. Does that make sense? So this guy is just a name of a variable. But I'm just telling you in this name, this is the table that is there. In this name, this is another table that is there. So now is those two results that I'm now using for my analysis here. Does that make sense?
All right. So yes. Do you have like a use case because like a scenario where you likely want to use a create view versus a
So like the use case, so the use case we are just painting here is based on our data set. But the main use case is anytime you have a query that depends on multiple subqueries. So last week we worked on subqueries, right? So now that subquery, rather than writing query inside query, you can write them separately outside, then merge them with a single query. And that's when you use CTE. Does that make sense? So anything you can write with subquery, you can do with this guy. And this guy is most of the time more neater because you write your query out separately. And it's not that you are putting query inside query and all those things. So, but the main thing is know that it exists and it's a way to optimize your scripting. And it's not that direct, like might be something that you might not be using for some time, but it's good you have it at the back of your pocket. Use it anytime that is required. Yes. Any other question? All right. So let's skip this and let's move to the next topic. Hey, 4 minutes. Okay, maybe we just do rank and we can call it a day after the rank. So for the rank, like the name suggests, it's just that you are trying to order things sequentially. So that's what you use rank for. And sometimes they request for maybe second most selling product. Now, we've used minimum, we've used maximum. But if they're asking you for second most selling product, that becomes a challenge because which kind of mathematics do you want to do that we define it as a single query, like minimum or maximum, right? And that's where rank comes in. And your rank, you can rank across anything. It's quite wide, just like student performance, all those things. You can attach rank to it. So here, there is a request. So let's solve an example. So create um, a rank of customers based on total orders made, right? So now, you know that we have my result, orders made. So if I say select star from my result, if I say select star from my result, so if I run this, I have all these customers, right? The next thing is they want you to rank. Although you can sort descending, it will give you everything. But if they want you to use the rank method, how do you solve this? Right? So in order to write any rank function, so you can add, you're adding an additional column to your script. So I can rank, rank. So there are three methods of using rank. We have row number, we have dense rank, and we have just rank where we are using it. So let me just use the rank one. So just write rank. I was thinking to change it to a function. Wait 1 minute. Rank. Is he not seeing it? So I'll just select start from my result, rank over. So over means what do I want to use to rank it, right? And in this case, what I want to use to sort it is rank over order by what? I have total order, right? And I want it descending. So see now, I'm ranking by my total order descending. Sometimes if you're doing rank, maybe across branch, maybe you want to know top selling products by branch. In that case, you need to partition. So there's a function you can partition. So you can partition by a column within your data set. So I can say partition by these specific columns, right? So I can come here, order by. So if I run this, good. Can you see what it has done? So you put this guy that is having total of 10 orders, and he's putting the guy as the first. Oh, I didn't put the name as, I can say my rank. I can say this is my rank, right? So that's my rank. So if I run this, it will give it a name as my rank. And now, so taking, so I told us that we have 3 ranks. So we've used rank now, and you can see what this one has done. It started from 1. So how many people are having 7? We have 7, 7. So we have 2, 2, right? It gave them 2, 2. I was thinking it will jump to, why did the guy jump to 5? Wait, I want to see something. Oh, okay. 3 people have to. So you can see what rank is doing. So rank gave the first one, because 3 people are having 7, it assigned 2, 2, 2, 2, 2 to them. Then the 6, this one is having 6. The guy said, okay, 1, 2, 3, 4. The guy assigned 4 to this guy, right? And because of that, there is dense rank. Dense rank will say that after 2, you should go with 3. So if I come here and I change this guy and I change rank to dense rank, dense DNSE. I think dense rank. Let me confirm. So if I do dense rank, okay, good. You know what rank was doing that the guy continued to 5? Yes, you can see what dense rank is doing. So dense rank is saying after 2, we have 3. Yes. And I said there is also row number. All of them, they are doing rank. So somebody will ask that when is the best time to use any one of them? It depends on whatsoever you want to do. But row number, yes, that's row number. Row number will just assign 1 to the end. It won't care, maybe they have the same number. All those spaces where we have 7, 7, 7, row number will not send them. They just assign row number to them. Can you see? The guy just fire 1, 2, 3, 4, 5, 6 at the end.